We, as GI oncologists, have been jealous of some of the other diseases because they've really made some great strides in using the sort of minimal residual disease assay to make treatment decisions. And I think our heme colleagues really led the way with this. And we look over there at them and say, well, you're really making good, smart decisions because you have this data, right? It's very useful. We want this. We're jealous. And so we now have data mounting up, particularly in the colorectal cancer space, that we can use these kinds of assays to inform our decisions. I think we in GI oncology will have a lot to learn from our partners in hematology about how best to incorporate this kind of testing. As a GI cancer specialist, I don't really do the heme testing, right? But our general oncology friends, they do all of it. So they're actually going to have a good familiarity with the realities of this test, the applicability of these tests. So I expect a fairly rapid uptake of this kind of testing in our general oncology community.
There are different ways to test for MRD, molecular residual disease, and there are two major ways to look for alteration that can identify tumors on a microscope or submicroscopic level. One is a tumor-informed test, meaning we sequence the primary tumor of a patient, really identify a unique signature of mutation that is characteristic for the individual's patient's cancer, and then follow the patient's blood longitudinally over time to see whether these mutations emerge or are present even after the surgery. Then there are tumor-agnostic tests, like we know certain mutations are common in certain cancers, like RAS mutations, APC mutations in colorectal cancer, and we can develop tests that can, cover, let's say, a one-size-fits-all for patients that cover most cancers of patients. Now, the sensitivity, which is a big issue of these tests, is different. A tumor-informed test is about 1 log rank more sensitive than a tumor-uninformed or non-informed test, a one-size-fits-all. So the molecular profiling, whole exome sequencing of the primary tumor, identifying genes and mutation that we can track later is actually probably the best way forward at this point in time. When we use tumor-informed testing, we have to follow certain logistics. We have to get the surgeons on board, for instance, that we have a tumor specimen sent to a profiling lab right up front so that we have the information available and a test can be built for each individual patient that can then allow us to follow these patients longitudinally with high sensitivity. At this point in time, the logistics are being worked out, and I think we've been quite successful, for instance, in our place to operationalize this. And I do believe that this is really probably the way forward to test patients with high sensitivity for minimal residual disease.
It's very, very important for all of us to remember that circulating tumor DNA is a better test if you have already tested the tumor, meaning you already know what's broken, what genes are broken in the tumor, and therefore you know what fish you're fishing for. And so if you find one, yes or no. So it's better to have what we call tumor-informed circulating DNA. But the other piece that's been very interesting about this is that let's say you have a RAS mutation or some other HER2 targeting. Well, then I can find the presence or absence of that particular mutation in your blood. So if I'm giving you a treatment that targets cells that have that mutation and that goes away, that means I've done a good job. My treatment's worked. But what we're seeing as a result of that is that other cancer cells are growing up. That kind of cancer we took care of for the moment, but its buddy over here who doesn't have that same mutation is now becoming the dominant cancer cell in the pack, if you will. And so what we can do over time with this technology is see what subclones of cancer we're actually treating at the moment. Where this becomes really important is this concept of re-challenge. So you gave the patient treatment A, you stopped treatment A, the marker went away, and then it's, say, 6 months later, you do another test, and the marker for treatment A is back up. And so you know there's been regrowth of that kind of cancer cell, which means I can use that medicine, again, re-challenge. And re-challenge we have done sort of using our best guess. This will give us the kind of information we need, particularly in the biologics, to use that much more wisely.